Hello everyone. Again, I am here with some new questions based on statistics and ML. Those are important in terms of interview. So let's discuss those questions of wasting time. So the first question is for these three events A, B, and C. They have given some conditions like A and C are independent, B and C are independent, and A or B are disjoint. Also, they have given the values like P of A union C equals to 2 by 3, P of B union C is 3.4, 3 by 4, and P of A union B union C equals to 11 by 2, 12. So we have to calculate the value of PA, PAB, and PC. So I have written all the things, whatever is given here. And after that, we need to simplify a bit this equation. So we all know A union C, we can write it as P of A plus P of C minus P of A intersection C. So as they have given A and C are independent, we can write the intersection C as A probability of A into probability of C. So after simplifying, we are getting this equation, and similar for P of B union C. As B and C are independent, we have written as P of B into P of C, and this is the equation we have simplified from this equation, from this equation. So after that, we need to simplify this equation, and here in this case, A and B are disjoint. So for that, after simplifying this, we are getting this simplified version of that equation. Like since the A and B are disjoint, so this thing will be 0. A intersection B intersection C. So this is the final equation. So we are just written all the equation that we have simplified from the main equation. So you can see here this probability of A, probability of B, and probability C minus P of A, P of C minus P of B, and P of C. So P of A plus P of C minus P of A, P of C. This is the first equation. So let's put the value here so that we can get any of the value from this third equation, and also we can put the second equation's value also. Like you can see here, P of B minus P of B minus PC. So let's put that thing from the second equation, and after putting all that, this is the equation. So after putting all that, we are getting the P of C value as 1.2, 1 by 2, sorry, and that we have to put that P of C in the equation 1 to find the P of A value. So after putting the P of C value, we are getting the P of A as 1 by 3. And now only P of B is pending. So let's put the value of P of C in the equation 2. This is the equation 2. So we are just putting the value of P of C to calculate the value of P of B. And after putting all the things, we are getting the P of B value as 1.2. So the P of A is 1.3, P of B is 1.2, and the P of C is 1.2. So the second question is, consider two random variables X and Y with joint PMF. PMF is probability mass function given in the following table. So they have given the table. We have to calculate these questions. So find probability of X less than equals to 2, comma Y less than equals to 4, and find the marginal PMF of X and Y. Find P of Y equals to 2 and X equals to 1. And at the very last, we need to state that the X and Y are independent or not. So let's going one by one. So the first thing, we have to calculate the X less than Y less than 2 and Y less than 4. So for that, we can get four conditions. Like we can as they have given X less than equals to 2 means it can be 1 or 2, and Y less than 4 means it can be 2 or 4. So these are all the cases that we have to employ, like probability of X equals to 1, we can Y equals to 2. Also, we need to consider X equals to 1, Y equals to 4, X equals to Y equals to 2, and X equals to Y equals to 4. So we are just putting all the values from this table, and after putting all the values of table on the table, we are getting the answer as 9 by 24. So next question, like we find the marginal PMFs of X and Y. So let's calculate the marginal PMFs of X first, then we'll move for the Y. So for X, like we will consider only the X. So for X equals to 1, we need to add all these values. For X equals to 2, we need to add all these values, and for X equals to 2, we need to add for all these values. So let's add those values, and let's calculate the PM of X. So a probability of X equals to 1 is coming as 1 by 6. x equals to 2 is coming by 3 by 8 by adding all the values. X equals to 3 is coming as 11 by 24 by adding all the values. So similarly, we have to calculate for y also. Like y equals to for y equals to 2, we have to add all these values. Y equals to 4, we have to add all these values, and y equals to 5, we have to add all these values. So let's see the values. Like probability of y equals to 2 is coming as 1 by 2. Probability of y equals to 4 is coming as 1 by 4. And similarly, y equals to 5 is coming as 1 by 4. So let's move to the C, question C. So we have to find here probability of y equals to 2 by x equals to 1. So the formula is like whenever this type of things are given, so we are able to like apply some formula. Like this is the formula. So this is the actually the simplified formulated version. So this is the probability of x equals to 1 comma y equals to 2 divided by probability of x equals to 1. So after putting all the values here from the table, we are getting the value as 1 by 2. So this is the result. And after that, we have to like state like the x and y are independent or not. So we can say it is x and y are independent if they verify if they are actually satisfied this equation. Probability of x equals to x, y equals to y equals to probability of x equals to x into probability of y equals to y. For all values of x and y, we need to check this equation that it is satisfying or not. So here I am actually showing for 3 or 4 values, but already I checked for other values also. So you can do the calculation for other values. So let's see the 3 values first. So we are considering x equals to 1 and y equals to 2. So this probability of x equals to x and y equals to y is coming as 1 by 12, and multiplying that the answer is coming as 1 by 12. So those are actually equal. And also for x equals to 1 and y equals to 4, the condition is satisfying. Also for x equals to 1 and y equals to 5, the condition is satisfying. And also I have calculated for other values also in rough paper, but I have not included here. All the values are coming same only. It satisfied all the conditions. So we can say the x and y's are independent random variables. So that's all for the statistics. So let's jump into the machine learning questions. So the first question is, what do you understand by pruning in a decision tree, and why do we require pruning in decision tree? Explain it. So what is pruning? So pruning in a decision tree actually refers the process of cutting back parts of the tree, especially leaves, branches. Like why we are actually doing this pruning? To prevent overfitting and improve the tree's generalization ability, so that it can predict the unseen data, with the unseen data well. So basically, we all know like decision tree is prone to overfitting. So which means they may memorize the training data rather than understand the underlying pattern. So when a decision tree is too large, like it's too big, then it may be maybe become overly complex and fit too close with the training data, and also it can capture the fluctuations in the training data, so leading to poor performance in the unseen data. So that pruning is necessary to address this kind of issue. By removing the unnecessary nodes or the branches, we can deal with this issue. Pruning basically, in a simple sentence, pruning basically helps us to simplify the model and to reducing its complexity, and also it improves the ability to generalize well to new or unseen data. So there is actually two types of pruning are there. One is pre-pruning and other is post-pruning. So pre-pruning means it actually stop the tree construction early before it become fully growth, and the post-pruning is actually also we can say it as cost complexity pruning or just pruning in general. This involves growing the tree to its full size and then moving the and then removing the parts of it. So that's all about the pruning. So the next question is, how do you choose a machine learning algorithm for a problem statement? Explain a brief. So it's a it's a kind of tricky part to choose a machine learning algorithm. So at the very first, we need to identify what kind of problem we are actually dealing. Is it a regression, or is it a classification, or is it a clustering? So accordingly, we know like some algorithms are there. Those are actually specialized for these cases. So we can employ those models, like those algorithms. And also we need to access the characteristics of the data, that like the data set size, in the data missing values are present or not, whether it's numerical or it's categorical or it's text based. And also we need to check the relationship in the data. Are there any linear relationship? So if there is any linear relationship, then we can employ linear regression or logistic regression. If there is any rather than the linear regression, if some linear relation, if some other relations are there for complex relationships or non-linear relationships, we can employ some complex algorithms like decision tree, random forest, and neural networks also. So the choice should also take into the account the need for model accuracy versus computational efficiency. So neural network and the ensemble methods typically offer higher accuracy, but the cost of greater computational resources. Basically, the cost of the training with these models are a bit high as compared to the simple models, where simpler models are easier to interpret. Their interpretability is a bit high as compared to the complex models like decision tree, random forest. So to get the best performance, ensure the multiple algorithms using like cross validation and fine tune with them with the hyperparameter optimization. So this is the actually a mostly used technique in today's world. Like many people are using this, like they are actually applying different models in their data, and they are actually also applying the cross validation. Also, they are fine tuning with the hyperparameter optimization. After they are after that, they are actually choosing the best model from all the models based on the accuracy and based on the prediction power. So this is the choosing, like this is the process to choose a best machine learning algorithm for our problem statement. So the last question is, what is model explainability and why it is required? So the answer is in the question only. The model explainability is actually a process to understood to actually uh, tell the human how the inner working is going on. It involves educating how the model makes a decision based on the input features. It basically the model explainability is actually process of the like internal working of the algorithm that can be understandable by the human, so that they can understand like how the algorithm is working, and they accordingly they can like make informed decision. They can interpret it. So why this model explainability is required? So the model explainability can build trust in the model by making it a decision making process clear. Also, it provide transparency essential in sensitive areas like healthcare and finance. Also, it can assist to identify different kind of errors, biases, or the areas for model improvement. Also meets legal requirements, the mandate explainability in automated decisions. Also, it ensures ethical use by preventing discrimination and unfair biases. And also, this model explainability can facilitate adoption by helping user understand and trust the model. So by seeing the internal working of the model, human can trust the model bit as compared to the complex model. Those are not interpretable. So also it can ensure organization can be accountable for automated decisions. So they can rely upon it by seeing the model explainability of any algorithm. So that's all about today. These are all the questions, very important question in terms of interview. So thank you. So that's all.